Good morning, my viewers. This is Ayodele Samuel Jude, aka Samuel Dino, the Smart Tutorial founder. This channel will always be available for you to point out the basics that will always enable you to excel in your topics. And today we'll be looking at chemistry, and the topic we are looking at today is atomic structure. Under this topic, we'll be pointing out some basic things that you need to know as a student if you want to understand chemistry better. If you really want to understand chemistry better, you have to have these concepts in your memory so that when you get to higher level in chemistry, it becomes more easier when you come across some further topic. So this topic is necessary because I believe some teachers, though they try their best, but there are some confusion that that students do come across when talking about the atomic structures and atomic number and then the mass number. So just like what I told you, I will be giving you the basic things that you need, not just the elaborate topics. So under the atomic structure, you know, atomic structure. When you talk about atoms, you are talking about elements. So there is no real difference between element and atom. Just like elements is the smallest particle of a substance, atom is also the part of that element that can undergo chemical reaction. So there is no difference between atom and element. So you can say atom of an element. So atom of an element. Do you get it? So we are going to look at the structure. Basically, when we talk about atomic structure, we are also referring to what the structure of what element. Usually, spherical shape is used to depict the structure of an element. Basically, that is, the structure of an element is depicted with what? With spherical shape. So when you talk about the structure of an atoms, what makes up these structures? What make up the structures are just three main particles: the proton, which is the symbol P, the neutron, the N, and then the E minus, which is the electron. So I will be using the symbol so that it sticks to our memory. Now, if you look at this spherical shape, this is the shell, that is the outer part of the atom. We have the centra, which is the core. Now, inside the core of this element here, we have a lot of proton and neutron. The number depends on the type of element. That is, the protons and the neutrons, they reside in the what? In the innermost parts of the atom. That is, if you're looking at the structure of an atom, the inner part, which is the core, which is the nucleus, you can call it nucleus or the core. There lies the proton and the neutron. The proton is the positively charged particles of an atom, while the neutron, like the name neutron, that is what? No charge. While the electron is the negatively charged. Now, for the electron, they revolve around the outer layer of the elements or atom. Don't forget, just like what I told you earlier, that is the electron, E minus, they revolve round. So the number of the electron depends on the atom you are referring to. Also, the number of proton or the number of neutron depends on the atoms you are referring to. Let's take, for example, hydrogen. Hydrogen simply means it has what? Hydrogen is element 1. which means it has one proton. That is just it. And it also has one electron. Remember, we said no charges. So another thing I want us to take note here is that most of the name of the element, or let me say the atomic number of an element is the number of proton in that element. Most of the times, as science student, this applies to me also. I do take atomic number because most of the time we talk about electronic configuration in chemistry. So when we talk about electronic configuration, my mind do go to atomic number, which is very wrong. Even though the number of proton and the number of electron, they are almost, for a neutral element, they are equal. The number of proton in an element and the number of electron, just like hydrogen, a neutral element now. If P is 1, electron is 1. Because P is 1, the atomic number is 1. That is, the atomic number talks about what? Proton. But most students, we do misplace it with proton when we are referring to atomic number. So atomic number talks about what? Proton, not electron. Take notes. But the electronic configuration, which is what we do mostly in chemistry, talks about the number of electron. Now, looking at the position of the structures here, you will notice that it's very easy for the electron to go out than for the proton and neutron to go out of the structure. So that means in chemical reactions, it is the movement of electron that take place when we talk about chemical reaction. In chemistry, the movement of electron either out of the element or coming inside the element is what leads to chemical reactions. The textbook will not tell you this. That is the fact. So the electronic configuration talk about electron, yes, but the proton is the one that talks about the atomic number. The proton is very heavier compared to the electron. The neutron is also heavier compared to the electron. Therefore, the mass number, which is still the same thing as mass weight, mass talk about weight, right? So that is, the mass number is the sum of the proton and the neutron. Yes, that is the weight of an element. Now, you cannot use the electron to determine the weight of an element. Let that stick to your brain. You will not get that in the textbook. The proton and the neutron, they have weight. They are heavier. Both the proton is heavier than the electron. The neutron is heavier than the electron. So it's the addition of the proton, the weight of the proton and the weight of the neutron give the weight of an atom or of an element. That is, the mass number talk about what? Both, that is the sum of the proton and the neutron, because they are heavier than the what? Electron. The weight of the electron is very, very, very small. Very, 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 very small. I hope. So if you want to talk about the weight of electron, you have to use it in relative to the weight of the proton, because the weight of the electron is very, very small. So it's more, the proton and the neutron, they are held by a strong force inside the core of the atomic structure. So they cannot easily go out, they cannot easily be removed. But electron can be get excited easily with small amount of energy and they will move out. Now, if an electron move out, then the neutral elements, let's take for example chlorine. Chlorine is 17. The chlorine is 17. The electron is 17. Now, this 17 most of the time, which is still the same thing as the atomic number, and don't forget, the number of proton is always equal to the number of electron. That is where the mistake, the confusion always come up. That is, the atomic structure, the atomic number is 17. That is, the proton is 17. The electron, which is also what? 17. Now, the atomic number of chlorine is 17, which is the proton, but the electronic configuration is the same thing for most of elements. It's the same thing with the number of the electron is almost equal to the number of atomic number, but you cannot use the atomic number to form the electronic configuration. That is, this E is the electron here. The electron is 17. The electron is 17. The proton is 17. This particular 17 is for electronic configuration. Then the proton, which is still 17, is the atomic number. So it's very easy for students. When you know the atomic number of an electron, you can use it to get the electronic configuration of that element. But that does not make electron number to be equals to the atomic number. Take note of this. This is very, 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 very crucial. The atomic number talk about what? Proton. The mass number, which is talk about weight, is most of the time the neutron also. Most of the time the neutron is almost the same thing with the number of electron. All these numbers, they are always almost equal, not equal at all times, because we have different type of chlorine. That is where in some cases you see chlorine having 35.5 for the mass number, but it is almost equal. If you look at 17 plus 17, 17 of the proton plus 17 of the neutron is 34, right? But if you check the mass number for some chlorine is 35.5. We are not going there for this video. The purpose of this video is just to tell you that even though you can use the electronic, which is electron number, to get the atomic number, is not equal. Now, we've talked about mobility. Mobility, that is the electron rotate, revolve around the axis, revolve around the shell of the atom. That is, electron is what? Very mobile. Why this one? They are held by a strong force inside the core or inside the nucleus of the element. Now, even though the electron in chlorine can move out, leaving chlorine with, let's assume one electron left chlorine. That is chlorine now having 16. Now, the electron is a negatively charged that left. That means this chlorine will be what? And let's assume chlorine accepts. It's very easy for chlorine to accept electron, not give. Chlorine 287. So chlorine, it can easily accept an electron to make it 18. But this chlorine will not remain the same as chlorine anymore. That is, the chlorine, the electron that is coming from another element, the electron is not coming from, is not conjured spiritually from anywhere. It's another element is giving out the electron. Let's take, for example, maybe sodium 11. It can easily give out 1. So if the electron, which is negative, is coming to chlorine, now the chlorine will become what? 18. It does not change the number of proton and neutron in the chlorine. The mass number of that chlorine will still remain as 35.5. But the electronic configuration of chlorine will change. That does not change the atomic number of chlorine. That is why I was trying to tell you that the atomic number is different from the electronic configuration. Atomic number talk about proton. Why the electronic configuration is the number of electron. So it is the electron that is coming in. That is for this. If an electron is coming inside to give what? Chlorine. Now, electron that is coming inside, electron is negative, and is coming inside a neutral body. What happens to the body? The body becomes what? Negative. How many negative? 1. That is, chlorine that have its electronic configuration to be 18 will be what? Cl minus. That is different between the Cl minus and the Cl. Ordinary Cl will be 17. Why Cl minus will be what? 18. There are some elements that can gain electron. There are some elements that can lose electron, depending on their depending on their electronic configuration, not their atomic number. I hope I've made some things clear in regards to electronic configuration is different from what atomic number. So the chlorine, which is Cl, the Cl minus now, which is now 18, the proton will still remain as what? 17. The neutron will still remain as 17. The same thing happens to other elements. Let's take, for example, maybe sodium. For sodium, I don't want to rub it off. That is why. For sodium is 11. This sodium is neutral. That is, the proton is 11. That is, the atomic number is 11. The electronic configuration is 11, but that does not make the 11 for the proton is different from the 11 of the electron. Now, what move out or move in is the what? Is the electron. That is, here the proton is 11, the electron is 11, the neutron is assumed to be, it is more than 11 because sodium is 1123. But let's just assume it's 11 because we don't talk much about the neutron. Because they are not charged particles. Now, the atomic number is this proton 11, not the electron that is 11. Then the electronic configuration, which is the E minus, is 11. It is the electron that is going out that is coming inside. Now, look at this. 2, 8. This one will be 281. 281 according to electronic configuration KLML shell. Don't forget, this is the shell we are referring to. We have not the shell, we use one shell to depict the shells in these structures. That does not mean that it is just one shell. If you look at some other topics, you will understand what I'm saying. As a science student, I think this should be very clear. That is, this shell, we have several shells. Just like I told you earlier, that I put 2 protons here does not mean that only 2 protons will be here. It depends on the element. So element sodium is 11. The maximum number of electrons that can occupy the first shell is 2, followed by 8, 8, 8, 8, 8, 8, 8. That is, the element we always like to obtain the octet state. Octet, 8, octagon. So octet state. So here, the electronic configuration from here will be what? 2, 8, 1. That is, 1 electron can go out. It's very easy for sodium to lose 1 electron. So if sodium is losing 1 electron, sodium will now become 10. That is, the electron E minus is what? 10. Sorry. E minus is 10. Then the proton still remain as what? 11, because nothing, the proton is inside. It's inside. Nothing can remove the proton and the neutron except special force. It's head inside the nucleus of the what? Of the inside the core of the atomic atom. Now, let's go back to what we are trying to point out here. Here, for the proton moving out, for the electron moving out, it remains 10. The proton will still remain as 11. The neutron will still remain as 11, which at the mass number for sodium is 23. So that will be the neutron 23. That is 11. Since we said mass number is proton plus, neutron, that is 11 plus 12. That is sodium here. The neutron for sodium will be 12. 11 plus 12, that will be 23. But that is not what I'm trying to point out. What I'm trying to point out here is that since the sodium has lost an electron here, this sodium will not remain as Na. Now, 1 electron goes out, something negative move out of the life of someone, the person will be happy. Negative moving out, you'll become happy. Someone that is sick, you becomes happy when you are healed. So it's like a negative substance move out, a negative particle move out here. So this one will become negative moving out. You become happy. That is what Na plus. Depending on the number of electron that is going out, that will determine the number of plus that will be here. This ordinary single plus is +1. If it is 2 electron that is going outside, that will be +2. I hope you get it. So that is just some basics that I wanted to point out, some of the confusions that students do encounter under atomic structures. I think we've been able to talk about that is the proton number give the name of the elements. Since the proton does not change, so the name of an element won't change. Like what happens here, the sodium still remains, even though the electron is going out, the sodium still remains as sodium, only that they modify the name. The name sodium doesn't change because another element is having atomic number 10. Don't forget, it's having atomic number 10. Another element is having atomic number 18. So the atomic number is different from the electronic configuration. So that is how to form plus and minus in elements. But you have to understand the atomic structure. If you understand the atomic structure very well, it will enable you to understand other topics in chemistry. And always remember, most of the chemical reactions, oxidation, reduction reactions, all the different chemical reactions, is the electron that is moving that enable elements to join together. Is the electron that is moving that is causing some chemical reactions. So the proton and the neutron, they are intact inside the nucleus of an atom. And I think I made mention that the mass number, which is the weight, talk about weight, is what? The weight, what has weight in the atom? Electron doesn't have weight. The weight is very small, very, 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 very small. So the weight, you can only know the weight in relative to the weight of proton. So the proton has weight, the neutron has weight. So the addition of the proton and the neutron give the weight to the structure of an atom, which simply means the mass number. So don't forget, though at the beginning of chemistry syllabus, they talk much about atomic number. And I think that is the point where students get carried away with atomic number. And then whenever they talk about electronic configuration, they might go back to atomic number. No, atomic number is different from electronic configuration. Atomic number is number of proton. Mass number is number of weight. Electron does not have weight, so electron is not part of mass number. The sum of the proton and the neutron of an atom is the mass number. And the electron is what easily move out of the shell to form, for an element to form ions, that is charged particles. So thanks for watching this video. We always be there to give you our best in every possible way so that you can understand the basis. Just click the like button if you like the video, and also you can share with your friends. And don't forget, you can always send us pictures. You can form some elements. Just write out elements. Try to check if when the electron move out and when the electron comes in, form ions from different elements without looking at your textbook. Form it by yourself. Just try it as a student. Practicalize. This will enable you and help you to understand the chemistry subject very well. Chemistry is very simple. Just get the basis. Other topics will fall in place. Is that taken? So you can just take a picture of what you have done, send it to us on our Facebook channel, just Smart Tutorial. Send a picture as a post or as comments. Take the picture, send it to us there. So we'll always be there to help you and to let people learn also from you. So thanks for watching. I'm Samuel Jude Ayodelis, aka Samuel Dino.